Good day, everybody. Today we are going to study scalar and vector quantities. Scalar quantity. A scalar quantity is a quantity that has magnitude or size without direction. Examples of scalar quantities are length, mass, and others. For vector, a vector quantity is one that has both magnitude as well as direction. Examples of vector quantities are force, displacement, velocity, acceleration, and others. Vector representation. There are different ways of representing a vector quantity. One method is graphical method. In this method, a straight line with an arrow is drawn like this. A straight line with an arrow. The length of this line represents the size or magnitude of that vector, while the arrow indicates the direction where the vector is moving to. There are other methods of representing vector. It can be represented by letter with boldface. For example, A with boldface, B, C, and so on. And then we have parallel vectors. Parallel vectors are two or more vectors moving either in the same direction or in opposite direction. And we have different types of parallel vectors. Types of parallel vectors. One is called like parallel vectors. Like parallel vectors. The second type is unlike parallel vectors. Unlike parallel vectors. In the first case, like parallel vectors are two or more vectors acting at a point and moving along the same direction. For example, if you have a body here being moved by a vector f1, and then there is another vector acting on that same body, f2, and two of them, both f1 and f2, they move in the same direction. And so, the resultant of these two vectors is the sum of the two vectors. Resultant, we can call it, we can use R to represent the resultant of the two vectors. R is equal to F1 plus F2. Assuming F1 here is 10 newtons, while F2 is 6 newtons, then the resultant of these two vectors, two like parallel vectors, is the sum of two of them, and that will give us 16 newtons. On the other hand, for unlike parallel vectors, these are two vectors that are acting at a point and are moving in opposite direction. Unlike parallel vectors, for example, you have a body here, and one vector is moving this body in this direction, while this one is moving it in the opposite direction. Supposing here remains 10 newtons, while this one is 6 newtons. So the resultant of these two vectors will be the difference between these two vectors. And the difference is F1 that is bigger than this one minus this. F1 minus F2. And that will be 10 minus 6. 10 minus 6, which is 4 newtons. Now, the next thing is laws of vectors. There are many laws of vectors. One of them is parallelogram law of vectors. Parallelogram law of vectors. Parallelogram law of vectors state that if two vectors acting at a point are represented in magnitude and direction by the adjacent sides of a parallelogram, their resultant is represented in magnitude and direction by the diagonal drawn from the common point of that intersection. That law can be expressed diagrammatically this way. If you have vector F1 here and another vector F2, two of them they act at a point here. So we can represent these two vectors in this way. This one here, this direction here is this. This vector is this one. This one is this. And the diagonal is this. We can use R to represent the diagonal. In this case, assuming the angle between them is 60 degrees, if these two vectors F1 and 2 are acting at a point 60 degrees between each other, then the resultant can be found using cosine rule. And from here, this will be R squared. The diagonal of this parallelogram is R squared is equal to F1 squared plus F2 squared minus 2 F1 F2 cos theta. So this formula can be used, and if we assign numbers to these values, we can solve for
resultant vector. Apart from this, we can also use Pythagoras theorem to look for the resultant of two or more vectors acting at a point. Supposing we have two vectors acting at right angle to each other. For example, if we have F1 acting at right angle to F2, and assuming F1 here is 3 Newton and F2 is 4 Newton, we can get the resultant of these two vectors by getting a right angle triangle. Diagonal will be in this direction. This length is the same thing as this length. This is a right angle, meaning this is 3 Newton, while this side is 4 Newton. So if F is the resultant, then we have from Pythagoras theorem, F squared is equal to F1 squared plus F2 squared. F1 is 3 Newton and you square that. F2 is 4, you square it. This 3 square is 9, 4 square is 16. This will give us 25. Therefore, resultant F is square root of 25, which is 5 newtons. And supposing we have more than two vectors acting at a point, we can still get their resultant. For example, if we have a point there, and there is one vector dropping this body vertically upward, and if the size of it is 10 Newton, and another force dragging the same body downward, and the magnitude is 10 Newton. Another one dragging into this direction, and it's 20 Newton. Another one to this direction, and it's 17 Newton. So what will be the resultant of these four coplanar forces? To solve this problem, we have to solve it step by step. Step one is we will find the resultant of forces acting vertically. We keep the resultant somewhere. Then we find the resultant of horizontal components. We now join the two to get the right angle triangle. So from here, resultant of this one will be, let us assume that this is F1 and this is F2. We can call this F3 and this is F4. So resultant of the vertical component R of Y will be, since they move in opposite direction, their resultant will be the difference between them. That will be F1 is bigger than F2, so F1 minus F2. This will give us 10 minus 6, which is 4 Newton. Then R of X will be the same thing. F3 is bigger than F4, so we have F3 minus F4, which is 20 minus 17, to give us 3 Newton. So from there, we now have that the vertical component of this vector is R of Y, and the horizontal component is R of X, which is this R of X, and Rs is 3 Newton, while this one is 4 Newton. From there, we can get a rectangle, and then the diagonal of it is the resultant of this vector. So that corner there, since this is the right angle triangle, invoking Pythagoras theorem, we have r squared is equal to rx squared plus ry squared. That gives us 3 squared plus 4 squared. This will give us 9 plus 16, which is 25. Therefore, r alone is the square root of 25, which gives us 5 Newton.